There are two students are having a race to the finish line. Student A run on a smooth and empty track. Student B run upstate. The time taken for them to reach the destination is not the same.
Well, today we are going to talk about the simple but powerful concept that help chemical engineer, which is the residual property. Actually, the extra 4 seconds is like the residual property. It tells us how much time to take when we face the real condition compared to the ideal and perfect condition.
So in thermodynamics, when we talk about residual entropy and residual entropy, we are basically measuring how much extra or less a real gas behave compared to an ideal one under the same condition.
The generic residual property is defined as the difference between an actual property and the ideal gas state properties at the same T-amp, P. Here is the equation, where M is valid for any molar property, including V, U, H, S, or G. There are mathematical expression and P equations specified for residual property. Even wonder why ideal gases don't always follow the rules we learned? That's because real gases aren't perfect and engineers need a way to measure how far they drift from ideal behavior. That's where residual properties come in. Real gas does not behave ideally because they have interaction and repulsion between molecules, and this affects things like enthalpy, entropy, and Gibbs free energy. Here are key in residual entropy. It quantifies how much the randomness or d-order, entropy, of a real gas differs from an ideal gas, again, based on compressibility data. While for residual enthalpy, this measures how much energy is extra or missing in a real gas compared to real gas, based on pressure and temperature changes. And for residual Gibbs energy, it tells you how the real Gibbs energy differs from ideal due to non-ideal pressure effects. It's zero when the gas behaves ideally. In real-life industrial processes like designing reactors, separators, or pipelines, gases don't behave ideally, especially at high pressures or low temperatures. Residual properties allow chemical engineers to correct ideal gas calculations to more accurately predict how gases will behave in the real world. Residual properties are like an extra effort that your car needs on a bumpy road.
Have you wondered why potato chip inside always say critic? It's not about magic, it's about science.
This is because of a technical modified atmosphere packaging. In this process, inside air is replaced with nitrogen or carbon dioxide to prevent spoilage and keep the potato chips fresh longer.
In filling this package, gases often transport and store under high pressure and low temperature. At these conditions, gases like oxygen, carbon dioxide do not behave like ideal gas anymore because due to the molecule interaction and the energy shift.
To accurately calculate how much gas to use and what pressure is set for both package and food, residual property is used to correct for non-ideal gas behavior.
Here will be the calculation by using ideal gas law.
Here will be the calculation by using residual property correlation.